Hi, Professor. Today, me and my teammate Manpreet Kaur, we are going to discuss about the different kind of simulation models on the topic of customer support system, and this is the final project presentation for system modeling and simulation project. And our main topic is about the call center. Today, everyone knows about the call center. So, what do you mean by call center? When you need to provide the services to any of the businesses, then you need to take care of all the kind of difficulties that comes in or the queries that comes in the business that will be taken care of taken care by the call center. And why do we need the call center? It's because of the customer satisfaction that we need to provide. Because of the customer satisfaction, we need to grow our businesses. And clients, we have a lot in many businesses. They have a lot of clients that they feel a lot of technical issues, warranty policies. They want to know about the promotional offers and the order status, or replacement or billing, any kind of difficulties they can face. And if they'll face any kind of difficulty, they can just directly call to the service center, and they can try to fix the issue with that by calling a call center. And today we are going to discuss about different kind of simulating models. And these are the simulating models that we are going to describe. It's the first one is discrete event simulation, that we'll be describing by Arena software. And then we have Monte Carlo simulation, then agent based simulation, which will be representing by NetLogo software. Then we have system dynamic simulation that we'll be describing with the Venn diagram that we have created. And then from here, my teammate Manpreet Kaur will be going to explain uh, about some of the simulation models.
Hi, Professor. Now I'm going to represent the discrete event simulation arena that as you can see we have explained the 7 logics or in this diagram, and it's a whole process of our call center. And but the whole clear image you will see in the arena model, as we came up with some logics. And first one is like customer. There are major type of calls, like one is technical call, sales call, order status call, product replacement call, and all other calls. Basically these are the logics which we have used in the arena. And now we came up with the input modeling, and according to the data, the random data that we have collected from our customer service company. And as me and Shubham, we both are working in customer service company, and we had a discussion with the manager, and we collect the data with his help. And so we came up with the results that as you can see, this is the customer call rate, and this is customer service rate. That and next is this is the arena simulation results. Basically as per the 10 replications we have, as you can see, we have total we have attempted 709.90 calls. Basically it's a 710 calls, and one call is for the logic one, as if we are going for the overall result. So we have attempted 711 calls, and one was the logic call. That is because whenever the time period of 10 hours is completed, it will not create more entities or the variables. So as you can see, we have completed 414 calls and declined 295 calls. And in this we have represented that how many calls are belongs to which type of call. So you can easily see, even in the report we have already mentioned that. And next we came up with the Monte Carlo simulation. So it is a basically the Monte Carlo simulation is based on the probability, like how many times we have like we can measure the probability of the call types. So as you can see in the first graph, we have a number of call types, and we came up with the time required. and that like suppose if for the technical issue we require at least 20 minutes, and number of calls are 95. So accordingly we came up with the probability is 0.11, and then we came up with the cumulative probability. And according to the cumulative probability, we came up with the random numbers. So we have just given the range. And as in the second diagram you can see, and this is the one person is going to handle the calls which are regarding the higher level technician. Like basically he can attend multiple calls because he's already like trained. So we came up with the average time, that is 15 minutes. And so after calculating whole waiting time, we came up with the result that our average waiting time was 23 minutes and 12 seconds. And the average time, so average service time was 15 minutes. And here we have represented that how much time we required in the like in the technical issue, promotional offers. So this is the whole chart. And now Shubham is going to explain net logo. So he came up with it.
Hello again, Professor. And now we are going to discuss about the agent-based simulation that we have performed on the NetLogo software. And now I want to show you the basic representation, how we have tried, how we prepared this. Okay, so here's the code for this simulation project, and we'll be attaching with the with the source file. And if we have the number of calls, number of agents, we are representing the number of calls with the sheets, and number of agents with the number of worlds. If we'll click on the setup, then you'll be able to see the number of worlds that are 45 initially, and number of calls that are 75, and the patches that you are able to see, it's due to the usage of the server. And you'll be able to see that there's nothing on the that nothing has been plotted on the graph. So if we'll click on the go, then each wolf will try to eat the sheep. Whenever the wolf will try to overlap the sheep, that means that it is taking that call. Means right now these number of the white sheep that you are able to see right now, these are in a queue, and the number of patches it shows that this is the server usage that you'll be able to see in the system. And if you'll click on the go, then you'll be able to see that these shapes will try to catch these wolves will try to catch all the shapes. Now the sheeps that the wolves that you are able to see on the screen, these are the number of agents that are on the call, still on call. When you hit on go again, then you'll be able to see that everything has been gone, and there is no server usages has been done. And there's an end of shift, so there is no call at the end of the shift, no agents, and there'll be no server usage. And you'll be able to see that in each day they have taken 495 calls, and the waiting time was 290. So this is the running project for on the NetLogo software. And this has been represented in the presentation as well. Okay, and this is the output analyzation of the NetLogo that we have explained in the report as well. Now we have tried to explain the simulation same on the Venn diagram as well, and I want to show you the functionality of that as well. Like this is the number of calls in a queue. Means if you are in a call center, then you'll be getting the incoming calls and the outgoing calls as well. So in incoming calls, there'll be any kind of issues like technical, promotional, warranty, delivery, or services. So they need to they'll be contacting the service agents. And if you talk about the outgoing calls, that means they have the higher technical issues. Means you need to just provide the customer satisfaction to your client, or there might be some security reasons, so that you cannot trust your some of the agents, so they can just give their credit card or debit card information. As in this COVID-19, like most of the agents are working from home, so they cannot provide the authority. So they have some authorized people so who can take the debit or credit card information. So they'll be taking the outgoing calls. So whenever you are doing the outgoing calls or incoming calls, so there'll be a fixed number, and that'll be coming in a queue. But there'll be a number of agents, they'll be taking the calls. So if you look into the logic, then I'll be showing you the logic of calls in queue. That means the incoming calls plus outgoing calls minus the number of agents on call, means the number of agents has been taking calls, they'll be subtracted, and the number of and and these are the number of calls in a queue that is being left. So we have provided with the calls tree diagram on that one, and we have also provided uh, with the this is the cross tree diagram, and this is the output analyzation of the whole Vensim diagram. And we have created some of the activity diagram, class diagrams, use case diagram, but unfortunately we are not able to show that use those use case diagrams and the sequence the state transition diagram on the PPT due to the lack of the time. But I would like to show you about the activity diagram here, that how this is going to start and how it is going to end. Means this is the customer part that we have provided, and this is the support system level 1. Once the customer will start entering the they'll contacting the level 1, if they'll be able to fix the issue, then they'll be checking this is the complaint issue or the merchant issue. If there's a merchant issue, then they'll be transferring the call to the level 2. And if this is the uh, sorry, this is the complaint, and then the level 1 will try to solve the issue. If they'll be if the level 1 agent will be able to solve the issue, then the case will end. And if they'll not be able to solve the issue, then they'll be transferring the call to the level 2 agent, and they'll be handling the call. And then it may cause in the outgoing call as well. So same, we have represented some of the classes in the class diagram, and we have mentioned this in the report as well. And I will talk about the conclusion. So we came with the conclusion that we have calculated the customer call rate and customer service rate by using the arena simulation. We can identify which type of call is taking more time, like the technical call, service call, or these kind of simulation that we have performed. And what kind of if we have performed the Monte Carlo simulation, then we have it helps us to check the average service time and waiting time of the call. In the agent-based simulation, that is, we have prepared on the NetLogo software, that will provide us the estimate that how many agents are more required for the next day of the shift. Okay, and if the business strategies will be enhanced with the use of simulation models. Thank you so much, Professor.